The Parker probe survives the closest pass to the Sun ever made. The Parker probe survives the closest pass to the Sun ever made. In the early morning hours of December 27th, NASA received a signal from space that was expected with some tension. In the early morning hours of December 27th, NASA received a signal from space that was expected with some tension. The Parker probe, which studies the Sun through very close flybys, issued a brief transmission indicating that it was operational and in good condition after becoming, in the early hours of the 24th, the closest spacecraft to the Sun, at a distance 10 times closer than that of Mercury. To protect its instruments, communications with Parker were discontinued shortly before the maneuver. Now that contact has been restored, NASA expects to receive accurate data from the close approach to the Sun on January 1st. This mission aims to analyze the solar corona, the region surrounding the Sun that is 1.5 million degrees Celsius hot. The data it will collect will allow a better understanding of some of the most violent phenomena of our star, which can generate on Earth the so-called geomagnetic storms affecting our technology. The spacecraft that has touched the Sun. The Parker spacecraft was launched into space in 2018. Since then, and through trajectory corrections facilitated by close flybys of the planet Venus, it has been following orbits ever closer to the Sun. The first of these close approaches took place on November 6, 2018, and at a distance of 24 million kilometers from the star. The milestone achieved just a few days ago has taken place in orbit number 22 and consisted of a passage at only 6.1 million kilometers away from the Sun, beating its own record of approach achieved in the previous orbit. The maneuver has also served to surpass the highest speed ever achieved by a spacecraft. Parker moved at no less than 191 kilometers per second. The mission is scheduled to end next year. Specifically, its last orbit will be completed on June 19, 2025, at which time the spacecraft's speed will reach 200 kilometers per second. A protective shield. During the approach operation, the spacecraft has had to withstand temperatures of approximately 1000 degrees Celsius, and its scientific instruments have been protected by an 11.4 centimeter thick heat shield composed of carbon and a ceramic layer capable of reflecting a large part of the light it receives. The design of this shield, which works in conjunction with a heat dissipation system, represented a major engineering challenge and required 10 years of work. It measures 2.4 meters in diameter and weighs just 73 kilograms. It is able to withstand 1,400 degrees Celsius and ensure that the equipment it protects can operate at a temperature of just 29 degrees Celsius. The most exposed parts of the ship, which cannot be protected by the shield, are made of titanium, molybdenum and zirconium materials and alloys, and can withstand up to 2,500 degrees Celsius. Likewise, the cables used are made of niobium and capable of operating under such extreme temperatures. Understanding the Sun. The Sun is surrounded by a huge region called the corona, where temperatures of the order of 1.5 million degrees are reached. This fact is surprising since the surface of the star is at 5,500 degrees Celsius. Scientists believe that it is in the solar corona where the mechanisms that launch enormous quantities of particles into space as a result of changes in the Sun's magnetic field are activated. These flows of material are called solar wind. The solar wind particles, mainly protons, electrons and helium nuclei, carry a lot of energy and are harmful to life. Fortunately, the Earth offers us very effective natural protection, with a magnetic shield that is capable of trapping the solar wind before it reaches the surface. However, if solar emissions are very intense, launched into space by abrupt eruptions called coronal mass ejections, the Earth's magnetic field becomes saturated, and it is then that geomagnetic storms are generated, with disturbances that can seriously affect communications and even satellites and essential surface infrastructures such as power plants. It is important to note that even in these saturated conditions, the Earth's magnetic field continues to function almost perfectly as a protector of life on our planet. Because of the impact that the solar wind and coronal mass ejections have on an increasingly technological world, it is logical that the study of the Sun's corona is one of the priorities of astronomical research. Hence, the importance of the Parker mission, the first to transit through the solar corona. Parker's excitement. The spacecraft is named after Eugene Parker, the American scientist who in 1958 predicted the existence of the solar wind in a paper that at the time generated intense controversy and opposition from much of the scientific community. 4 years after the publication of the study in 1962, NASA's Mariner 2 spacecraft confirmed from space the presence of the surprising particle flow that Parker had announced. On the day of the launch of the Parker Solar Probe, August the 12th, 2018, the 91-year-old scientist, surrounded by his family, was able to contemplate the beginning of the journey of the spacecraft that was named in his honor and whose goal was to practically touch the sun.